So we had a little look at ocean acidification a couple of weeks ago on the World's Most Exciting Classroom. And we've actually got another experiment that we'd like to do just to see what actually happens when, or how, I should say, ocean acidification actually happens. Because ocean acidification is one of the effects of climate change. And climate change is a pretty big subject. It can be a little bit confusing and there's lots to it. So let's break it down a little bit for anyone maybe who is still a bit confused or who wasn't able to see that session a couple of weeks ago. So climate change is happening, amongst other things, because of too much of one particular gas in the air. This gas is called carbon dioxide. And this gas is being released into the atmosphere because we are burning fossil fuels. These are things like coal and oil and natural gases that have been underground for millions and millions of years. So we're digging them up and we're burning them. And the reason that we're burning them is to create energy. So we burn them so that we can drive our cars and fly our planes and our buses and our trucks. It also provides us electricity for our houses so we can watch TV and have the lights on, which is pretty useful. Things like plastic are also made by burning fossil fuels. So all these different things that humans are doing is creating carbon dioxide, which is going into the atmosphere. And then it's getting absorbed into our oceans. And once it's in there, it's causing a few problems. We're going to head front of house. Emily, I'm going to ask you to come with me because you're going to play a part in this. And we're going to see what actually happens when that carbon dioxide enters the water. So we're going to pop back out. And just to make sure that we are really understanding what's happening, we need to know a little bit about something called the pH scale. Now, the pH scale, if you haven't heard of it before, is a way that we can tell whether a liquid is acidic or alkaline. And if you have a look on the wall here, the pH scale goes from 0, and that's a liquid that is very acidic, like vinegar. And it goes all the way through neutral to alkaline, which is the opposite of acidic. Now, these different states are represented by a colour. And if you take something called universal indicator and you add it to some water or any liquid really, it will tell you where on the pH scale your liquid is sitting. And if we were to think about our oceans, then they're sitting at about 8.1. They're about here on the pH scale, which is great. It's neutral. We're happy with that. But what happens to our ocean when carbon dioxide is added? What happens to the levels? We're going to do a little experiment now to find out. I've got a few friends who are going to help me along, and these friends are all very invested on the health of the ocean. And they are going to add carbon dioxide to their beakers to see what happens and how it changes. So I want everyone to say a big hello and a big welcome to my friend, Myrtle the turtle. Everyone give Myrtle the turtle a wave. Come on in, Myrtle, come on in. Grab yourself a beaker of ocean. Excellent. I also want everyone to say a big hello and a big welcome to my friend. It's Coral the mermaid. Hi, Coral. Thanks for joining us there. And last but most certainly not least, this is an episode all about octopuses. So can everyone say hello and welcome to Emily the octopus? Come on in, come on in. Amazing. You're going to take that for me. Lovely arm wave there. Myrtle, come on in, come on in. Our gang here have got 30 seconds. They've got 30 seconds to blow as much carbon dioxide into their beakers as possible, and we will see who can change the pH level the most. Before they start, have a quick think. Have a little think, turn to your neighbour and think, which way is it going to go? Is it going to get more acidic? Is it going to get more alkaline? Is it just going to stay exactly the same? I don't know. We're going to find out. These guys are going to do a competition. Who do you think is going to be able to change the carbon the most? I'm not sure. Let's cheer on the mermaid, the animal, whoever we think is going to change it the most. They're going to have 30 seconds. Can you help me count them down? In 5, in 4, in 3, 2, 1, go! Add that carbon, guys. Blow, 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 blow. How can they change their water? Is anything happening? Is it getting more acidic? Is it getting more alkaline? They've got 10 seconds left. Blow, 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 blow. I'm definitely seeing some changes here. The water is changing. The actual chemistry of the water is changing. And we've got 5 seconds left. 4, 3, 2, 1. Everybody stop! Oh my goodness. Gang, hold out your beakers of ocean. What has happened? Well, they started off green. They started us over here at 7 and they have not become more alkaline. They have gone all the way over. I think corals has changed the most. It has come to number 2. It has got significantly more acidic. So I think first things first, we need a round of applause for coral. Excellent job, excellent job. And doesn't that just go to show the carbon dioxide that's in the atmosphere, when it gets absorbed into the ocean, becomes more acidic. Now, that's the end of our experiment there. We are going to send all the information out to you so you can do this experiment at home or in your classrooms. And once you've done it, I want you to have a little chat. I want you to have a little bit of a think about what you can do as an individual, as a class, maybe as a school, to try and reduce the amount of carbon going into the atmosphere. We probably don't all own factories, so that might not be something that we can control. But I reckon there would be some things that we could all do that would help our ocean be healthier and happier and safer. And I'm really looking forward to seeing what ideas you all come up with.